So what are the main approaches to create a whole brain simulation? I mean, I've seen a number of people who are attempting to do so. One of them is Dr. Henry Makram. Another one is perhaps, I think, IBM's Dharmendra Modha.
Dharmendra Modha.
Yeah, Dharmendra Modha. So, is there a difference between their approaches and your approach, and
Yes.
how do you go about creating a whole brain simulation?
Yes, there's a big difference. And the difference popped up when you said, well, when you started talking about a whole brain simulation. See, that's actually what Markram is doing.
Mm-hmm.
And Dharmendra's project is an entirely different project. We can talk about that separately. But if you look at the Blue Brain project, where does the information come from that's going into that project? They're taking a bunch of different animals, lots and lots of rats, and they study in them things like what is the average, what is the distribution of distances at which a neuron branches, a typical neuron in some layer of the neocortex will branch, and how does it connect to other neurons of different types. So they get a huge database of statistical data. That statistical data allows them to build a composite model. This is a model built up of information taken from thousands of animals and lots of different studies, and it's probabilistic. Mm-hmm. And then, after they've built the typical structure of a cortical column, then how do they set the connections in there? They set them according to these probabilistic tables, and they give them some weights that seem reasonable, and then they can run simulations on there where you see oscillations that are typical. Those oscillations are largely dependent just on the duration, where how long a neuron cannot spike after it is spiked. So you've got this after hyperpolarization, and also on recurrent loops that exist in the system. And you can see the propagation of activity in a sense that you would expect to see in a rat if you just looked somewhere in that cortical area. And that's great, and you can learn an awful lot from that. But what do those synaptic connections really mean? They don't actually mean anything, because these are not the connections that came from a rat that had a certain experience and maybe learned its way through a certain maze. You take this model and you put it in the maze, and it's not going to know what to do, because it's not that rat, and it didn't set those synapses that way for a reason. You can train the simulation to do something, but again, there's a big problem there. You've got a huge system with lots of neurons, lots and lots of synapses. It's what we call over-parameterized. It means it has so many parameters. There are a multitude of different ways of setting those up so that it will achieve the task that you're trying to get it to do. But there's no guarantee that that's exactly the way that it is in any particular rat. If you take a comparison, let's say we had a computer program that's supposed to produce one type of output, like let's say it's supposed to calculate some sum of different numbers or some equation. You could implement that in one way, and you could have 50 other implementations of the same type of program, and they produce similar results, maybe not exactly the same, and they go about it in all sorts of ways. And then if you're doing the simulation approach, basically what you're doing is you're sampling from each one of those, learning a bit about it, and then making a 51st copy that's slightly different than all of the other 50. And it produces some result that's somewhere in the range of what you expect. Now, an emulation approach, whole brain emulation, it would be take one of these programs and copy it line for line so that it produces exactly the same output. And that is what the difference is. So you need tools that actually acquire the data from a very specific brain, from one individual rat or human brain. That's the difference.
So in your case, you're looking at creating an exact copy, and in the other case, basically you create a probabilistic, would it be fair to say a statistical model of a basically average rat or average human being, but not any existent individual?
Yeah, that would be fair to say. And I give it the shorthand separation by just calling one thing a simulation and the other an emulation, because we know the concept of emulation from computer programs where, let's say, you have a PC emulator that you run on a Macintosh, mm-hmm. and then you hope that all the programs you're running on your PC run exactly the same way in that emulator. Mm-hmm. That's where that comes from.
I see. Yeah, that's a very important distinction indeed. So perhaps now is the time to go a little bit more into the details of your work. Um, should we start with Halcyon Molecular? How does Halcyon Molecular and your work there fit within your overall goals?
So as I said, there are a few details there that I can't go into, but I can give you a general outline.
Absolutely.
So I'll start with a little historical bit. I was not initially planning to work for a sequencing company. What I wanted after working for, basically after starting a neural engineering department at a nonprofit in Spain, I wanted to go and work for a company that was really involved in doing circuit reconstruction in the brain. And so I was looking into, for instance, working for the startup Brain Corporation that Eugene Itzkevich started in San Diego. And, well, that wasn't quite the fit. So I decided to look elsewhere. And I discovered that Halcyon, well, they approached me and asked, hey, would you like working here? And I thought, well, why would I work there? It's a DNA sequencing company. And then I visited them and I found out that there's a lot more to it. They're really interested in the long-term future and in what they can do when they have this tool. So they want to use this tool as a revenue source that they can use to start other very interesting projects that are heading towards curing disease and towards extending life and towards artificial intelligence and various other projects. And they're also interested in using the tool to acquire data that you would want to get, for instance, out of a brain. Say some of the most modern approaches to collecting information about all the connections in the brain, the connectome, is one of those that is being proposed by Anthony Zador, who works at Cold Spring Harbor Laboratories. And it involves building DNA barcodes that are specific for every neuron in the brain, and which would be delivered to the synapses between them. And then when you pluck out that information, you pluck those barcodes out of those synapses, basically, and you sequence them, then you know it's basically like pointers that are pointing to each other. Then you know this neuron is connected to that neuron. And that requires an enormous amount of sequencing of DNA, which is why, say, the tools built here, a high throughput method of DNA sequencing, that's exactly the sort of thing you'd be looking for. So now we have a tool that's actually applicable to the problems I'm interested in, and you have people who are interested in putting their work and their finances and their future profits into things like what I'm interested in. And it turns out that they're a fantastic bunch of people. So it was mostly that, actually. It's the people that drew me here. And so that's why I work for Halcyon.
And how is that different or similar to the work that you do with Carboncopies.org or the work that you have done previously in Europe or for Neuroengineering Corporation of Massachusetts?
Yeah. Well, I'll start with the work that I was doing in Europe. The work there was, it looked like a very promising job because I was offered the opportunity to start up my own department and to hire whomever I wanted to hire for it. And the only requisite was to come up with interesting neural engineering problems and solve them by, for example, building neural probes that would eventually become patentable or profitable in some way. But there wasn't a very short timeline on that because they had a great financing system set up for the next 10 years. Mm-hmm. Then, unfortunately, the financial crisis hit Spain. And the investors, they got a little worried and they wanted really quick results, which changed the type of project they were interested in. Mm-hmm. To the point where it really wasn't that interesting to me anymore. Mm-hmm. So it was a really great opportunity, but it just didn't pan out that well. So in that sense, it wasn't meant to be that different, but it just didn't turn out that well. Carboncopies is a different matter entirely. Carboncopies is something that Suzanne Gildert and I set up on purpose as a place for pulling together the network of people and the knowledge that is necessary to build a roadmap towards whole brain emulation. And it's really done quite a lot of that, actually, because we do have a very extensive network right now that reaches to just about everyone who's involved in the most cutting-edge work in the field. And we're putting out, or at least we will be in 2012, putting out a lot more fundamental information about it so that everyone can read the details of what is this actually and how does it work and how would it work, what is actually going on, what are the projects that are going on in that area. So it's a nonprofit, which means that people don't have to worry about are we associating ourselves with a certain company, what's going to happen to our data or things like that. I think that's a benefit when you're trying to build a network like that. So I thought that building a nonprofit like this was a better idea. And yeah, that's a large part of my effort, actually, keeping that going.
On your website, it says that you're basically looking into practical approaches toward what you call advanced substrate independent minds. That is transferring mind functions from the biological substrate to another substrate. So how far along that goal have you managed to get so far?
First of all, I'd like to say that we actually just call it SIM now. We call it Substrate Independent Minds. We used to say advancing in front of it, and that's still on carboncopies.org because we wanted to make sure that it's clear it's an action-oriented organization that's trying to advance this topic, not just a discussion hub or something like that. And you're asking now, so how much have we advanced on this topic?
How is